In Java programming, understanding exceptions is crucial for writing robust applications. Exceptions are events that disrupt the normal flow of a program's execution. When a problem arises during runtime, such as an invalid input, or an attempt to access a non-existent file, an exception is thrown. This lesson will guide you through identifying runtime errors and handling exceptions effectively. Don't worry if this feels new at first. This section covers what's an exception. An exception is an object that represents an error or unexpected behavior in a program. Exceptions can be classified into two main categories. First, checked exceptions. These exceptions are checked at compile time. The programmer is required to handle these exceptions, either with a try-catch block or by declaring them in the method signature. Next, unchecked exceptions. These exceptions occur at runtime and aren't checked at compile time. Examples include null pointer exception and array index out of bounds exception. They're often the result of coding errors. Identifying runtime errors, let's dig in. Runtime errors occur when the program is running. These errors can be caused by various factors, such as, let's walk through the main points. First, invalid user input. Next, file handling issues. Also, arithmetic errors like division by 0. The full list is on the slide if you want to review it. Identifying these errors is crucial for effective debugging. Java provides a mechanism to catch and handle exceptions, allowing your program to continue executing even when errors occur. Next, using try-catch blocks. The try-catch block is the primary way to handle exceptions in Java. The code that may throw an exception is placed inside the try block, and the handling code is placed inside the catch block. Here is a simple example. This slide introduces a class definition. Study the structure in the code sample. In this example, attempting to access an index that doesn't exist in the array throws an array index out of bounds exception. The catch block handles the exception and prevents the program from crashing. Finally block, let's dig in. In addition to try-catch, Java offers a finally block, which executes after the try and catch blocks, regardless of whether an exception was thrown. This is useful for cleaning up resources, such as closing files or database connections. Here is how you can implement a finally block. This slide introduces a class definition. Study the structure in the code sample. In this case, the message from the finally block will always be printed, ensuring that any necessary cleanup occurs. Now we're on creating custom exceptions. Java allows you to create your own exceptions by extending the exception class. This can be useful for handling specific error conditions in your application. Here is an example of a custom exception. This slide introduces a class definition. Study the structure in the code sample. In this example, my custom exception is thrown and caught, demonstrating how to handle specific situations in your application. In this lesson, we explored the concept of exceptions in Java, focusing on, there are several points on this slide. First, the definition and types of exceptions. Next, identifying runtime errors. Also, using try-catch blocks for error handling. Check the slide for the remaining items. By understanding these concepts, you're better equipped to write Java programs that can handle errors gracefully. Now put what you've learned into practice. You'll see a few items listed here. First, modify the exception example to handle multiple types of exceptions. Next, create a new custom exception and implement it in a small program. Also, experiment with the finally block by adding resource management code. Take a moment to read the rest on screen.